Okay, example 4. Figure 4 shows a combination of three capacitors, so C1, C2, and C3. So they all have its own values. A 20 volt supply is connected to the combination, so determine the you determine the effective capacitance in the circuit, charge stored in the capacitor, potential difference across capacitor C1, energy stored in the capacitor, and then the area of each plate in the capacitor C1 if the distance is given here and the region between the plates is vacuum. Okay, so firstly let us simplify the circuit here. So this will be this one, we will connect this one, so this is gonna become skip this part. Yeah, this is taking up your time. So gitu. Okay, so that is the simplified circuit. So this is 20 volts, so this is C1, this is C2 3. So C2 3 was connected in series, so 1 over C2 plus 1 over C3. So this is equal to 15 microfarad. Okay, and then we can then calculate the effective capacitance. This is connected in parallel, so this will become 115 microfarad. Okay, so that is the effective capacitance. And then you have to calculate the potential difference across capacitor 1. So we will be using the sorry, my cat was fighting outside. I think I'm a bit I'm not focused. Okay, right, so the charge stored in each capacitor, sorry, this should be B, C, D, E. Okay, so the charge stored in the capacitor is just basically Q equal to CV kan. So kita tengok C1, Q1. Okay, so for parallel circuit, remember the voltage is gonna be equal to the supply voltage. So V1 is equal to V23 equal to V, which is equal to 20 volt lah. Alright, so this you should get 2000 microcoulomb as the charge stored in the capacitor. And then we have to calculate the potential difference across okay, so we have to calculate the potential difference across, actually this is not C1, this is C2. I'll do the correction before I upload it in the Google Classroom. Okay, so the potential difference across C is the total charge stored. The total charge. Okay, so we have to calculate the potential difference across capacitor 2, and in order for us to calculate that, we have to firstly have the value of charge untuk Q2, right? So in order for us to do that, we will firstly calculate the total charge by using the effective capacitance punya value. So this gives us 2300 microcoulomb as the total charge stored in the circuit. And then the charge in, we can then calculate the charge stored in capacitor in this one here by using the concept of a parallel circuit. Okay, remember for parallel circuit, the magnitude of charge is not equal, so we should get Q23 equal to 300 microcoulomb. Okay, and then since capacitor C2 and C3 are in series, remember C2 and C3 are in series, the magnitude of charge is gonna be equal. So Q2 is equal to Q3, which is equal to 300 microcoulomb. Okay, now we can find the we can then find the potential difference across capacitor 2 lah. Okay, so it is equal to 13.6 volt. Okay. Okay, now question D, the energy stored in the capacitor is basically just energy stored in capacitor C3, so U3 is equal to half Q3 square over C3. Okay, so all the values are given, we've calculated it, so just substitute, so you'll get 9.58 times 10 to the power of negative 4 joules. Okay, and then lastly we have to calculate what? We have to calculate the area of each plate in capacitor C1 if the distance is 0.02 micrometer and the region is vacuum. Okay, so for that case we are going to use C1 equal to E naught A over D. This, you haven't actually entered the subtopic for that one, but that's okay, at least you know how to calculate. So just rearrange and you should get the area to be equal to 0.226 meter square. Okay, right, so that is a very long solution, but I hope you can understand what we are doing in this example. If not, again, you can ask me through Telegram. Okay, right, so that is the solution for example number 4.